All right, question number 31, a word problem. The function h of t equals negative 16t squared plus 30t plus 5, that is standard form, models the height of a football over time, where h of t, which is this item, this part right here, is in feet above the ground, and t is the number of seconds. You want to pay attention to your units of measure after the football has been thrown. Answer the following questions with complete sentences. What was the starting height of the football? Let's look at letter B too. What was the initial velocity? Well, class, we learned this already. When you have a quadratic equation in standard form, we know that this is telling us about the effects of gravity, which doesn't affect the height of the football when it starts or the initial velocity. The 30 is the initial velocity. The 5 is the initial height. We called that h sub 0. Now, I've experienced years of this where students will constantly flip these around. They'll tell me the starting height is 30 and the initial velocity is 5. But that doesn't make any sense, and the way you just logically configure this out is, think about this. When no time has gone by, when t is 0, if we plug t equals 0 into this equation, we will get the starting height. That's where the ball started before it started to travel. That was how high it was. When you plug t is equal to 0 into this equation, negative 16 times 0 squared is just 0. 30 times 0 is 0. You're left with the 5. That means that has to be the starting height. So please don't mix those up. It makes no logical sense at all. So what was the starting height of the football? You should write this in a complete sentence, and I'm not going to write it. The starting height was 5 feet. Anything like that. Here's your starting height, 5 feet. What was the initial velocity? The initial velocity was 30, and then your unit of measure is going to be your distance over your time, so height over time. So I'll give you your unit of measure. It's going to be feet per second. Feet per second. So the initial velocity was 30 feet per second. Let's take a look at number 32. It's the same question. This function, which is standard form, models the height of a diver over time, where f of x is in meters above the water. That's a terrible underline. Is meters above the water, and x is the number of seconds after the diver has jumped. Answer the following questions with complete sentences. What was the starting height, and what was the initial velocity? Well, we know again, our starting height is right here. That is h sub 0, or the height at time 0. This is our initial velocity. So what was the starting height of the diver? The starting height of the diver was 3.5 meters. 3.5 meters. What was the initial velocity? The initial velocity was 5. And then again, we do our height measure divided by our time measure. This is going to be meters. You can just put m divided by seconds. Meters per second. All right. Let's take a look at question number 33. The function f of x equals this equation. By the way, I notice now this is in vertex form. It's no longer in standard form. Models the height of a diver over time, where f of x is meters above the water, and x is the number of seconds since the diver started to dive. Okay, at what time is the diver at its highest point? Highest point. Let's think about this. If you drew a graph and you had time here and you had height here, and the diver is going to start off at some point and go up a little bit, and then they're going to finally come back down and finally hit the water. When we ask for what is the highest point, well, that's the vertex. And the time at the highest point is the x value. The height at the highest point is the y value. And remember, x is the same as h in this case. And the y value is going to be our k value because our vertex is h, k. So at what time does the diver reach its highest point? It's going to be at the h value of the vertex. And take a look at our equation. Here is a. We don't have to worry about a. Here is h. And here is k. Since our h value is equal to 1, that means the time the diver is at its highest point is at 1 second. So you'd write it as this answer as the time the diver reaches their highest point is at 1 second. Letter B, how high is the diver's highest point? Well, the diver is at its highest point is going to be where the vertex value of k is, and that's going to be right here, which is 3. So letter A is going to be at 1 second. Write that please as a sentence. And letter B is going to be at 3. And take a look at our unit of measure. It is meters. So my complete sentence is the diver's highest point is at 3 meters. All right. Number 34. The function f of t that is also in vertex form, I'm going to label my values here. A, and then here's my h value, and here's my k value. Okay, f of t is in feet, and t is the number of seconds. At what time is the diver at its highest point? We know that's going to be a vertex, h, k, and the time the diver reaches the highest point is right here. That's going to be the x value or time. This would be the highest point or the maximum height. But they're not asking me at what is the highest point or the maximum height reached. They're asking me for the time they reach the highest point. That's the h value. And because h here is 1.6, this answer is going to be at 1.6 seconds. And then how high is the diver at 2.1 seconds? Now here's a problem. This is different than this question. Last question, number 33, says how high is the diver's highest point? Here it says how high is the diver at 2.1 seconds. That's an evaluate question. You're going to take your function and plug in 2.1 for the number of seconds. So here's what I expect you to do. You should be writing the function value at 2.1 seconds is equal to -16 times. Now I should put all my variables in parentheses. I should do exactly what I teach you all to do. So I'm going to use a different color parenthesis. And my t value is going to be 2.1, close parentheses. And now I'm going to put in here minus 1.6, close parentheses squared, and then plus 10.5. Plug that into your calculator and you should get 6.5. Let's check that out real quick. So I'm going to put in -16 times, and now I'm going to put a second parenthesis, 2.1, close that parenthesis, minus 1.6, close that parenthesis, squared, plus 10.5 equals 6.5. Got it. So you're going to write that as a complete sentence. You're going to say the diver is, or you can say at 2.1 seconds, the diver is 6.5, and I think that's going to be meters. Let's see. 6.5, nope, 6.5 feet above the water. There's your final answer on that one. All right. I'm not writing those for the sake of the students who just copy answers over. So you should be listening to the video if you didn't know that answer, and you should have that answer written out. All right, question number 35 through 51. Now, I've taught you this strategy. When you're matching graphs with quadratic functions, here's the three things you should be identifying: A, H, and K. So look at the first graph. The H value and K value are 0 and 0 because our vertex is at 0, 0. So H equals 0, K equals 0. Let's do the next one. Let's just do vertex first. Here we have a vertex also at H equals 0, K equals 0. Same thing on graph C. H equals 0, K equals 0. So those we're going to need more information because the vertex is all at the same place. How about D, E, and F? Here the vertex is at 2, 0. So H equals 2, K equals 0. Here the vertex is at 0, 3. So H equals 0, K equals 3. And here the vertex is at positive 1, so H equals 1, and K equals 1, 2, 3, 4, 5. K equals negative 5. Now these ones, D, E, and F, will be very easy to find. Let's find those. Look at number 50. Number 50 has an H value of 1 and a K value of negative 5. And since this parabola opens up and this A value is equal to 1, a positive 1, this must be the correct graph. So F is going to be 50. Take a look at, here we go. Here is an H value of 2 and a K value of 0. So H, let's do this in a different color. We've got an H value of 2 and a K value of 0. I don't know why this disappeared. Let's fix this. This is K equals 3. So H value of 2, I don't know why I'm getting erasing here, class. I'm going to fix that. For some reason I'm getting things disappearing. Let's hope they stay up there now. Okay, look, here's our graph where H equals 2, K equals 0. So that must be 49. So that's going to be D. And let's go ahead and write this so we notice what we did. This one we had an H value of 1 and a K value of negative 5. Let's find another one where we have an H and a K. Looks like the only one is 51. 51, our H value is 0 because there's no X minus or plus anything, so that's 0, and our K value is 3. That matches this one right here, and sorry, because this was erased, that looks like negative 3. That was K equals 3. So that means this graph has to be E. So we've got D, E, and F done. Let's find A, B, and C. Now we need more information here, and now we're going to start looking at the A value. This is the only graph where A is negative. So since A is negative because the graph opens down, of number 35, 36, and 48, these are the only ones. Now I notice my numbers are really weird here, but that's okay. We're doing 48 here. This number, 48, must match graph C. It's the only one with a negative A value where H is 0 and K is 0. So now we're down to A and B. So let's take a look at this. Graph A is a compressed graph. Graph B is a stretched graph. So in this case, the absolute value of A is going to be less than 1, and this one, the absolute value of A, is going to be greater than 1. So look at which one is greater than 1. On 35, the absolute value of A is 4. That's greater than 1. That must be graph B. And on 36, the absolute value of A is less than 1. 1/4 is less than 1. That must be graph A. So use your strategy of looking at the vertex first, and then if you have a bunch of graphs with the same vertex, start looking at the shape. Is it compressed? Is it stretched? Is it facing down or opening down? Use that information to track down which equation matches. And that is the end of this side of worksheet number 2.